Today we are going to discuss the Bentham and Hooker system of classification. This is a natural system of classification in which number of morphological, anatomical and physiological characters they were compared amongst 97,205 species of flowering plants, which were further categorized into 202 orders. The order term that was used by Bentham and Hooker at that time is nowadays recognized as families, and they distributed all these families under 25 cohorts, which are nowadays called orders. So, for families, they use the term orders, and for orders, they use the term cohorts. Total 97,205 plant species they were classified under the system, and it was presented in 3 volumes of the book Genera Plantarum. So, this is a brief history of the classification. Then their major classification was that they divided plants into two subkingdoms, that is cryptogamia and phanerogamia. Cryptogamia are seedless plants. So you can see here, cryptogamia are seedless plants and phanerogamia are seeded plants. Further, cryptogamia included Thallophyta that had algae, then Bryophyta and Pteridophyta, and phanerogamia had Gymnospermia, which had naked seeds, means they are not enclosed with an ovary, and Angiospermia that had covered seeds. Further detailed classification was given for angiosperms, and they were divided into two main classes, dicotyledony and monocotyledony. Brief characters you have to specify in the beginning about these two categories. First is dicotyledony, means they have two cotyledons. Di is two, cotyledony is for cotyledons. Two cotyledons in a seed, then you call that dicotyledon. They have reticulate venation in leaves. Flowers may be pentamerous, bimerous, or tetramerous. The vascular bundles in stem are arranged in the form of a ring. In roots, there are 2 to 6 vascular bundles, and in stem, the vascular bundles are open and they have polygonal cross section. So we draw them this way. That is a polygonal cross section. Second category is monocotyledony, means there is present one, mono is one cotyledon per seed. The venation in leaves is parallel. Flowers are trimerous. Vascular bundles in stem are scattered. Vascular bundles in root are more than 8, so it is a polyanth condition. And they are closed, means cambium is absent. So there is no scope of secondary growth. That's why they are called closed. And when we see the cross section of the vessels, they are round. So these are the major differences between dicotyledons and monocotyledons, and between them the gymnosperms were placed under the class Gymnospermi, and it included orders Needales, Coniferales and Cycadales. This is the most primitive one that was kept in the last, and this is the most advanced one which was kept in the beginning. Now coming to the detailed classification of angiosperms, class dicotyledony was further divided into 3 subclasses depending upon whether the calyx and corolla is a distinct whorls or on the basis of the fusion of petals. So polypetally means petals are free and sepals and petals are distinct, means you will observe in the flower separate calyx and corolla, and in corolla the petals will be free. Then you keep those flowers under polypetally. Example here, this include 3 series that we'll discuss in detail in the next slide. Then gamopetally, again sepal and petals they are distinct, but here the petals are fused, that is gamo. It also has 3 series. Last is monoclemidae. This subclass has sepals and petals indistinct, means you will not observe calyx and corolla. Rather, there is present another whorl which is called perianth, and the individual part of perianth is called tepal, and it has total 8 series. Now coming to detailed of these subclasses. Polypetally is further divided into three series: Thalamiflory, Disciflory, and Caliciflory. Thalamiflory has either elongated thalamus or it has convex thalamus. So, because of that, the ovary is always superior. So, it's on thalamus, the ovary is placed and whorls are arising below. So, ovary is always superior, thus, the flowers are hypogynous, ovary superior. In Disciflory, the thalamus is either convex or it is flat. So because of that, if it is convex, then it will show the superior ovary, means all whorls are arising below the ovary. Whereas if it is flat, then we call that the whorls, they are half superior, half inferior, since they are arising from the same level. But in written part, we mention this as the superior ovary. Whereas and disky word is used because below the ovary there is present a nectar secreting disc in all members of this series. Caliciflory, in which the thalamus is either flat or it is concave. Now since it is concave, the ovary will be deep seated and all whorls, they are arising above the ovary. So here the ovary becomes inferior and all other whorls, they are superior. So here, and if it is flat, the condition becomes superior. So here you can have superior ovary as well as inferior ovary. Flowers are epigynous because the other whorls are arising above ovary, that is epi. They may be perigynous if the thalamus is flat, means half superior, half inferior. And here the disc is absent. So you have to remember the number of orders and families in particular series. So here we have 6, 4 and 5 orders and 34, 23 and 27 families. And the one in your syllabus under Thalamiflory is Crucifery, which is the new name is called Brassicaceae. Under Disciflory you have studied Rutaceae, that is the citrus family. And under Caliciflory in your syllabus you have Fabaceae and its old name is Leguminosae. Second subclass is Gemopetally, means petals are fused. We have three series: Inferi, as the name suggests, means ovary is inferior. And here mostly the number of carpels is 2. Heteromery, ovary is superior and number of carpel is always more than 2. Bicarpellatory, ovary is again superior but number of carpel is fixed, that is 2. Under this we have 3, 3, 4 orders. Number of families are 9, 12 and 24. In your syllabus you have Compostae and its new name is Asteraceae. There is no family under heteromery in your syllabus, but you can remember Primulaceae. And under bicarpellatory you have Solanaceae in the syllabus. Third subclass is Monoclamidae. This is quite an elaborate class which was further divided into 8 series. You cannot change the order of these series, so you have to learn it like C, triple M, D, A, U, O. You can make any mnemonic for this in order to learn the arrangement or the order. So C stands for Curvembry. You can write just one character for each. Curvembry means curved embryo. And here we have the example from C itself, Chenopodiaceae, where we have Chenopodium, which is commonly as Vathu. Second and third is Multiovulatae aquaticae and terrestris. Multiovulatae means ovules are many and plants are aquatic, and here the plants are terrestrial. You have just one family under aquaticae, that is Podostemoniaceae. It's Naceae. And under multiovulatae terrestris, there are 3 families, but you can remember Nymphaeaceae. Fourth is Micrembry, means micro, very small sized embryo. Here we have the example of the family Piperaceae. Piperaceae is after The genus Piper, that is black pepper. So there the size of embryo is very, very small. Fifth is deafnails. This is a separate group in which plants are woody. The carpel may be one or it may be bi to polycarpellary syncarpous condition. Here we have five families. You can keep in mind Proteaceae as an example. Proteaceae. Next comes Achlamydospore. Achlamydius means seeds are without testa. So there is no seed coat. So seeds are without testa. Just wait. So here seeds, they are without testa. So seed coat is testa. And here most of the parasitic plants, they are found under this series. For example, you have Centellaceae. Centellaceae is for centellum, that is chandan. You all know it's a parasite. Then another is Loranthaceae. Loranthus is also a parasite. Next group is unisexualis, means the flowers here are unisexual. So you have separate female and male flowers. An example for this is family Euphobiaceae. And Ordines anomaly, the plants which had monoclemidious nature, means there is present perianth, and they are not included in any of these categories. They were kept under Ordines anomaly. You can learn one example of the family Selicaceae. Selicaceae, to which the Salix alba belongs, which is commonly called willow. Okay, so you have to remember at least name of one family as an example to that series. Now, this was the first group, dicotyledony. Coming to the second group, that is monocotyledony, means we mentioned here that there is present single cotyledon in the seed. Here we have 7 series. Again, you have to remember the sequence of the series. So it is easily as mech, neg, mech, neg. This is order. You can make some sequence, some mnemonic for this. So here we have the first M stands for microspermy. Spermy word here refers to seeds. Means seeds are very small. They are dust-like. Very small, so there is no chance of endosperm. So they are endospermic. Ovary is inferior. You can just remember this first character. And here we have 3 families, but the one which is the most advanced family of angiosperms that has been kept under this, it is Orchidaceae. Second series is epigyny. Epigynous condition, you all know, means ovary is inferior. So here we have 7 families and you can learn Iridaceae. Next comes coronary. Coronary is Ankylicine. See here the only difference is that when you have the coronary means petal-like sepals are present. And here it means sepal-like petals are present. And normally here the perianth is highly reduced. It's just scaly, scale-like. Rest of the characters are same. In both the categories, seeds are endospermic, ovary is superior. So only difference is in the appearance of the non-essential whorls. And here you have the one in the syllabus Liliaceae. And under Calicini, where they have the sepal-like appearance, that is palmy. Palmy, to which all these palms, royal palm, bottle palm, they fall. Next comes nudiflory. Nudiflory, nudi is now, flower is not having any non-essential whorl. So perianth is absent here. Ovary is superior, seeds are endospermic. You can see these are all, most of the characters, they are common. They are same. Just from the name, that character is variable. So nudiflory means no perianth present. And here you have example Typhaceae. Typha, this is a plant which is found in the muddy bottom. Apocarpy. Apocarpus condition means there are present many carpels but they are free. And here the example is Najadaceae. And Clumaceae, this is the last series and this is the very, very elaborate family which is in most of the areas, this is the most dominant family found. growing, it includes grasses. So here the perianth is reduced to lodicules. See, here the perianth was missing. Here it is present, but in the form of very small structures like this around ovary, that is highly reduced structure called lodicules. And in typical two grasses is the inflorescence, that is spike of spikelet. So you can remember these two characters. And to this we have the family Gramineae, whose new name is Poaceae. As per the rule of nomenclature, the name of family should end with AC word. So for all those families where the rule was not being followed, the new name nomenclature has been assigned, but that doesn't mean that this name is invalid. We both these names are valid. Both are considered, they are correct. So that was all about the basic outline of Bentham and Hooker system of classification. In the end, you will mention its merits and demerits. First is, from the name, you can have an idea what kind of plants have been kept there. So it is a widely acceptable and very easy to follow system. Secondly, large number of characters, they were considered in huge quantity of plants, that is 97,205. So this is quite an elaborate system that was studied in very detail. The Ranunculaceae, under which I mentioned, that is the most primitive family that has been placed under the first series of Polypetalae. So technically, the primitive family has been kept first, and then the advanced families have been followed. So this is the correct order that should be followed as far as the evolutionary relationship is concerned. Then distantly related genera, they were placed under different groups. And the closely related, they were placed under the same group. Dicots, they were placed earlier to monocots, since we consider dicots are primitive to monocots. So these are the merits that where the system was followed. But there are certain demerits also, like gymnosperms were placed in between dicotyledons and monocotyledons. Though that is a primitive group, so it should be placed before dicotyledons. Then under gymnosperms, I mentioned there that Nettles was placed first, then Coniferales and Cycadales in the last. Though Cycadale is a primitive group as compared to Nettles, so it should be placed earlier. So that was another drawback. Then this system is not phylogenetic. This is not based on ancestral history. Then some of the members which were having similar characters, they were placed under different families. Then family Compositae, that is considered as the most diverse family of angiosperms, but that was placed under the first series of Gamopetalae, Inferi, though it should be placed at number 3. So Inferi should be actually not at number 1 but at number 3, because under that the family Compositae is an advanced family. Then Orchidaceae, which is a most advanced monocot family, that was placed just under first group, that is the Microspermi, though it should be placed in the last at number 7. And characters which were related to Androecium, they were not taken into consideration, that if there are, what is the number of the stamens, is there any fusion, is there any didynamous, tetra, monodelphous, any such kind of the condition which were mentioned in the linear system of classification. All those characters, they were not considered under this system. So these are the demerits, and with this you will conclude your question on the Bentham and Hooker system of classification. So that's all for today. Thank you.